Okay, here we go. So oh my gosh. Okay, I had it off, and I don't know why it bugs me so much, but I can hear my sound coming out of my iPad, which is like the most annoying thing ever. Anyways, I will have an example of what this looks like tomorrow. So really we can put it all together when I get back on Friday before we take the test, but it should be pretty obvious. You kind of fold on the fold line on both of them, and then you glue the backs together so it's double-sided, and then you cut slits. But we'll kind of save all of that. And so for now, I just want you to fill it out, and then we'll put it all together tomorrow when I get there. But I will have an example of one done. So if you want to do it, you could grab the example from the sub, or the sub can show you, or Miss Clee or Miss Fulton, whoever is there with you, how to make them. But anyways, I wanted to do the insides with you so that you have them done and ready, because this is, sorry, the kind of stuff that's on the test tomorrow. So hopefully it all makes sense, and everything works from there. So, product rule. These are all the rules that we've gone over in the last week or so. And so the product rule says that if a x is to the a power and x is to the b power, then x would be to the a plus b power. Okay, that's a rule. So you're going to add them. So you're going to add the exponents when it's multiplied. Okay, if they're written next to each other, you're just going to add them straight across. So on number one, or right here, 3 plus 4, that becomes x to the seventh. You're just adding the stuff that matches. But that's only for exponents, okay? These are all exponent rules. That's a whole thing. And so if they're not exponents, then they don't have these rules. So you're looking at 2 times 4. That still multiplies. 2 times 4 is just 8, like a normal 2 times 4. They're not exponents, so they don't have to have special rules. And then the y's, you have 3 right there, and you have 1 right there. It's y to the first power. So that would be y to the fourth power. 3 plus 4. Nope. 3 plus 1 is 4. Then this one, 5 has nobody, so it just stays 5. And then t is going to add. So you have -2 plus 8, which is t to the sixth power. So you don't have, even though -2 is a negative, and we talked about how negatives are going to go down into the bottom, you don't have to do that until you have a negative left over in the end. And we'll put those on here as rules. All right, so the next one, 2x's, but you have x3 and x2, which is x5, y2 and y3, which is also y5. Adding the stuff that matches. So whole numbers multiply, 3 times 2 is 6, exponents add. So there's 1x here and 1x here, so that's x squared. Then you have 2y's plus 9y's, 9, 10, 11. And then there's only one z, and he has nobody to go with him. So you leave him by himself. Same with this one, -9, no other numbers to multiply. And you add those up. 2 plus 10 is 12, plus one more is x to the 13th power. Okay, just like that. So that's the product rule. Then you get into the power rule. All of these have to do with multiplication. Okay, so everything on here, it looks like a multiplication problem. The top section is a product rule. Product means multiply. So that's going to be the rule about multiplying exponents, which really you add them. Okay, if you multiply two things, you add the exponents. This, though, is a power rule. Okay, so the power rule is a base, a power to a power. So x to the a power, like x is already to a power, the a, and then you're raising that to the b power. That's when you multiply them. That's what we learned today. So you have A times B. You multiply them. Anytime you see that arrow, if it's inside versus outside, you're going to multiply the exponents. The swirly like arrow that kind of jumps in. It's just like distribution. There's a parenthesis between two numbers. Normally you would distribute and then you would multiply. So it's the same concept. So this one would be 3 times 4. So x to the 12th, not 7. It's not adding. You're multiplying 3 times 4. Negative 2 times 4, both negative. Negative times a negative is a positive 8. Okay. On the next one, it only goes to inside the parentheses. So it's not going to jump onto the 7 because 7's not inside the parentheses. So you're looking at 7y to the 18th power. Because 3 times 6 is 18. But the 7's not going to change because he wasn't inside the parentheses. This one, negative times negative, positive 5. 7 times 7 is 49. That's 49. It doesn't really look like it. Here we go. I'll just make the line longer. And this last one does it twice because it's going to be 3 times 5, which is w to the 15th power, but that's still to the second power. So then you're going to have to do it again. I'm going to move it over. Hold on. So you're going to do it again, and 2 times 15 is w to the 30th power. All right? So even though it looks like that wasn't so bad, or it looked like that was tricky, it really wasn't so bad. All right. So that's the first one. Then you're going to do the next one, which actually is pretty similar. It's product of a product. No, power of a product. So if you're doing the power of a product, we did these today. It just has to go to both. That A outside has to go to everything inside. So x to the A and y to the A. So we definitely did those today. So it shouldn't be something new. So 3 to the x power. I really hope you guys don't hear this echo that I hear. It's super annoying. Um, so x to the third power. And then you have to go 2 times 3 y to the sixth power. Everybody inside the parentheses gets them. So if there's no exponents, remember there's those little tiny ones, and then you can do it from there. So everyone inside gets distributed. 2. So like this, the 2 goes on the 2, and it goes on the 4. So 2 to the second power. I'm going to scoot that over again so I have an answer space. 2 to the second power. And x to the 8th power because it's 4 times 2. But 2 to the second power is 4, and x to the 8th power. My phone keeps going off because I'm technically still doing DoorDash, but it's off now, so it's okay. Okay. So the next one is the same. 3 to the third power and 2 times 3. So negative 3 to the third power, and then 2 times 3 would be x to the sixth power. And negative 3 to the third power is negative 27, which I'm not going to make you guys do that because we haven't really done a lot of it, but you could get an actual answer and have negative 27 x to the sixth. Doesn't really fit in the box either. So I'm okay with either one of these answers as long as you keep it in parentheses. Okay, so we can leave those for now. You guys have a calculator, but I don't think we've done enough of the calculator. Um, so if you don't, you can just leave it the way that it is. So you just make sure that the 3 is in parentheses because the whole -3 is to the third power, not just the 3. All right, so same thing for this one. Everybody gets a 2. So 4 gets squared, x gets squared, y is already squared. So 2 times 2 means that y is to the 4th power. And then z is 3 times 2, so that's to the 6th power. So if it has a power, then you multiply it. If it doesn't have a power, then it just gets that power. -5 squared. -5 should be in parentheses squared. A, 2 times 3, and B just gets a 2. 2 times 3 is 6. All of this should be review. Last one, the 4 goes to both. 3, 4, A4. 3 to the 4th power is 81, so you could do that one. 5 squared, -5 squared is positive 21. No, I lied. It's positive 25. So you could do that one. All right. So that whole front page is all the properties that that have to do with multiplying. Power to a power or just regular product. All of those are multiplying. So yeah. Your homework today is going to be all the mixed practice side. So turn to the other page, which is properties of division. And we're looking at this one. So if you're going to do the quotient rule, quotient is just a fancy word for divide. If they're going up and down, remember I told you if it's going up and down, then you subtract the 2. You're going to subtract the exponents. Only the exponents. So on this first one, where it says 10 and 7, I guess I should zoom in on these because I just realized that they've been very small. Duh. I'm very sorry, guys. But this video will be posted, so if you miss something, you can watch it later because it'll still be on Canvas. So 10 minus 4 is 6. 10 minus 4. So you're subtracting. That's how you get x to the 6th power. Then those are going to divide because they're whole numbers. They don't have anything special that goes with them. So whole numbers divide and exponents subtract. So 12 divided by 3 is 4. And then 7 minus 2 is x to the 5th power. So whole numbers still have the same rules. They just divide. 5 divided by 15 on this one is going to leave us with 3 because 5 divided by 15 is 3. But the 15 is bigger, so the 3 is left in the denominator. And then 6 minus 4 is 2. Okay, so this line doesn't have to be this long. Hold on. It could be short. It's just x2 over 3. And I don't know what's up with that, but let's straighten that out. There you go. Okay, so whole numbers divide, exponents subtract. So I figured this way all of our examples will be just in the same place so that you don't have to look all over your notebook for them. So you can use this on your test tomorrow. Power of a quotient rule. Definitely not the color I planned on that being, so hold on. You guys don't normally get to see all my crazy uh color choices. There we go. I know it looks similar, but I promise you it's not the same. And I'm weird like that. So there you go. Quotient rule. It's the same thing. We started it yesterday. If you're in period 3, we didn't get all the way to the quotient rule, so I'm going to just show it to you now. But it's pretty much the same thing as the product rule. Everything inside gets distributed. So it distributes to the top and the bottom. So you multiply all exponents inside the parentheses. Okay? All the exponents that are inside, it goes to everybody. So x is going to get an A and y is going to get an A. It goes to both. So same thing here. 3 is going to go to both of those. So you end up with x to the third over 2 to the third. And I have space, so I'm going to actually write it. 2 to the third is 8. Because 2 times 2 is 4. That's how it works. 2 times 2, that makes 4. And then 4 times 2, there's 3 2's, makes 8. So it would be 8. But again, if you left it like this, I'm not going to take points off for that. You should be fine. Okay, the middle one, same thing. You're going to take the 2 to the 2 and the 2 to the x. So since y already has a 2, you just multiply them. 2 times 2 is 4. X does not have a 2, so now he just gets 1. And then over here, everyone gets a 4. So 3 gets a 4, and x gets a 4. You didn't have anything yet. And on the bottom, I don't know why it does that sometimes. Hold on. Okay, so on the bottom, 4 gets a 4, and y gets 5 times 4, which is 20. Now, 3 over 4 to the fourth powers, you could write those all out and distribute because I believe it just ends up being 3/4. 3 to the fourth power is 81. 4 to the fourth power is 128 because 16 times 16, I believe, is 128. But then you'd have to break down those, and I don't have a calculator in front of me to verify, so you can just leave it. If you have a calculator, you can do 81 over, oh my gosh, I'm getting tired. Ooh, 128. And then reduce them. So that's totally up to you. I don't have room for that. As long as you get that far, I'm okay with it. All right, so here's the next one. The negative exponent rule. Okay, we've done the negative exponent rule. Anybody who is negative gets sent down into the bottom like this. But, oh, that's not true. Once it goes down there, okay, so this one becomes 1 over x to the a power, goes down to the bottom, and then becomes positive. Once it moves, it becomes positive. If it's already in the bottom, when it is negative, then it goes up to the top. So it's just a, nope, it's x to the a power on top. So you can put it over 1 if you want, and that kind of looks like a 9. Let me fix that. You can put it over 1 if you want to, so that you know that means that it's on top, but it doesn't matter. So a x to the negative 4 goes down below 1 over x to the 4th. That's it. You guys were getting pretty good on the negative ones. You should be fine. On this one, 5 is just negative, but he doesn't have a negative exponent. Remember, all these rules only apply to the exponents. So this 2 is negative. So this guy's going to go down, but the -5 is going to stay on top because he didn't have a negative exponent. And on this last one, it looks like everybody stays except for these y's have to go up. So 3y3, and then on the bottom is 5x2s. And nobody combines. So hopefully that makes sense. Last one on this page is, I already used this color. Let's see. I'm gonna do exponent rules with 0. And we already know those. Any base 0 power equals 1. So 0 times 5 is 0, which equals 1. Then on this one, everyone's to 0 power. Okay? So even though you take the 7, we're gonna just write it out to show you. 197 to the -7 power. X, that's gonna be -21 power. And then Y is gonna be the 35th power. But they're all still raised to 0. And any 1 times 0 is 0. So the whole answer is 1. Everybody's going to be to 0 power. So let me write it real small. So it would be 197 to the 0 power, x to 0 power, y to 0 power. So it'd be 1 times 1 times 1. It's all just 1. So as long as the 0 is on like the outside, it's the farthest one out, then everyone's just going to be 0. But if it's like on this one, 15 is the innocent bystander. This guy's 0. So it's just 15. Anytime you have x's 0 power, it's just 1. And so it would be times 15 times 1. Now, that's it. So all these rules should be together. And you're going to try these examples. Okay? This one over here is that same one. Even though there's a bunch of junk inside here, okay, there's a whole lot going on. We don't have to deal with it because it's every single thing. I need a pen, not a highlighter. Hold on. Every single one of these is to the 0 power out here. I just scribbled all over it, but you get the point, right? So if everyone is to 0 power, then the whole entire thing is just going to be 1. If only z is to 0 power, then only z is 1, not everybody. Everybody's to the second power. So that second power has to distribute to the 8, to the 7, not to the 8. It's not multiplying 8. Remember, it's that itty bitty 1 that's on the 8. And then it's going to go to the little 1 that's on the 2. And then it's going to go to the 5 and the 1 that's on the y. So it goes to those. So even though there was z to 0, it doesn't change anything because that 0 is on the inside. So 8 squared, x, 7 times 2 is 14, y, 4 times 2 is 8. And we don't have to deal with the z to the 0 power. And then we get to this one, and it's 2 squared, x 10, and y 2, because that was 1 before, right? 1 times 2. Now on these, you can reduce it or you can leave it. I think for sure on this, like we should reduce these because those are the subtraction kind. So 8 squared is really 16, and 2 squared is really 4. So 16 divided by 4 is 4, and the 16 bigger, so it's on the top. Then you have 14 minus 10, so that's x to the 4, and the 14 is bigger, so it's on top. And y to the 8th minus y cubed is y to the 5th. And if everybody's on the top, I don't know what that is. Hold on. If everyone's on top, then you don't need anything on the bottom. All right, the rest of these you're going to practice on your own or with a neighbor. Get help from whoever's around you because these are fair game for tomorrow's test. Maybe not those super crazy ones on the bottom. Um, but as long as you do all the rest, then you should be fine. And we can go over those before the test if you want to. But the rest of these and the rest of this page up here are all fair game. Okay, so get help from Mr. Northup, get help from Miss Lane, get help from Miss Clee, from the sub, from Miss Fulton. You guys have all sorts of people in your wheelhouse that you can seek help from to make sure that this gets accomplished and that you're ready for your quiz tomorrow. All right, I will be back tomorrow. I will see you there. Bye.